Hi everybody, good morning. I have time this today so today to do this one was released this week. Linux threat detection number 2. There was one was a week ago I think. Explore the first action of an attacker after breaching a Linux server and learn how to detect them. So basically here the attack is inside the system. I think the previous one what it was a reconnaissance if I'm not mistaken. Um, what's going on here? The first one, I think, explore how attacker break into Linux system and how you can detect this in logs. So this one, detection when they are in, but this one, what they will do when they are in. So what happened next after threat actor enter the Linux system? What command this room? Let's be sure about it. Only subscribers, so you can read in the screen if you don't have a subscription. This is a premium room. What happened next after threat actor enter the Linux system? What command they run? Do they run? And what goals do they aim to achieve? In this room, you will find out the exploring common attack technique, detecting them in logs, and analyzing a real-world cryptominer infection from start to finish. This is more introduction here. Learning objective explore how to identify discovery commands in logs, learn common threat in endangering Linux server, know how attacker upload malware into their victim, practice your skills by unlocking a real crypto miner attack. Prerequisite, so you can say Linux threat detection 1, some of this, some basic Linux command is good. A lab, I don't want to split the screen. I don't. I'm using. You can use the split screen one. I'm using. Or use through your VPN. You have the IP SSH machine. I SSH in both way. I'm using this ghosty terminal. So I'm side machine, and I have another session here. We can play in both of them. Let's see what we get. So that's a scenario. What's inside the scenario? This one later on, the next task. So I have ghosty terminal, I have let's play what we can do with them. So this task 1 introduction and lab. Now let's start the room. Task 2 discovery overview. Now imagine suddenly appearing in Linux system and all you see a command line interface. Your first question will be about how you this is the way how Linux work, and most attack in Linux is through terminal and things like that. So bootnet give control over the victim to human. They're basically bootnets are try to brute force SSH or something like that. The attacker get a human attack, and then the human bootnet owner continue to attack chain and target Linux 7, usually looking for SSH and weak password and open port and things like that. First action, the first discovery command threat actor run on Linux system are usually the same, no matter which entry point they use and the goal they pursue. The only exception when discovery is skipped is when the attacker already know the target or simply want to install cryptominer and exit. So basically, for them the key is get money with cryptominer. There is no point to the destroy the Linux server or lock the user. Just went put their hidden cryptomania. It worked for you, and that's it. No matter who the victim is. Let's see. The basic is always same as usually when we do Windows. The PW directory, the ls, the environment variable, you name and say for the kernel, the release also for Linux, what version, the host name, ID, who I am, W, last cut, etc, sudo a cut, etc password, process and note where discovery, PSOX, top IP, IPR, what IPR do, forgot. The ARP SSS for the open port, netstat, same TNL, P, cloud and server discovery, system detect virtual if you are in virtual machine, ls mode for the model, I think kernel model uptime, pgrep, what's this one? As you can see, attacker only rely on the same command you will use. In the next task, you will learn how to tell bad from good. But one specific command should have your attention is who am I. Yeah, this is makes sense because a normal person, normal legitimate user don't use it because they know themselves. Why legitimate application rarely need to this command. Adversary almost always run it first after breaching the service. In fact, your SOC team can even consider creating detective detection rule for any who-am-I execution. Now, for example, okay, if we start the task now that follow the instruction, the first one is straightforward. They tell us run that command. Let's run that command. System this is for detect the environmental and of course we find it is on Amazon. So this one is straightforward, like detecting if you are in virtual environment. Now they said run ps aux and look for EDR antivirus processes. What's the full path detected anti-malware binary? Now this one I get confused because when I ran the first time ps aux I couldn't find it. I was looking and but usually that's what you do. You do usually because if there's something installed, you can use a grab and you just look for keywords like scan, EDR, malware. You don't need to type. You can type the whole word or just part. What else? Linux usually that calm IV. I think like calm like that. I think virus. If it's Microsoft, that's Sentinel. What other famous antivirus? Yeah, usually that's the usually we just scroll down uh, and then we find something. Well, I didn't find anything. Same things. Oh, we find something. Uh, so we have this one, the var, uh, and you can see which is now. I was confused because I thought var label with what mask mask and why there is a missing letter? Malware scan. What? Malware scan M. var label itra. What's wrong with my? What's that? var library ultra mail scan. What exactly? Mail scan. Why it's there is no L here? Sometimes what's going on here? Oh, mail scan. Why the f? He said L. Mail. Okay, let's go to what exactly that because it's it's not well known. So if you go ultra scan, we find this cat usage. It tell you Malscan uses cutting edge AI technologies to protect against 9 out of 10 known, so 9 out of 10. So which one is missing? Melo term and content do not access or share the source code or the product. Why? So if you go file and do malscan, it tell me it's bone shares, it's a share script, so you can just cut it. And he said, look what he do. While true, do the read minus t double nine double nine equal I scan no malware detected done. So it's not really just joke from TryHackMe. We can test it. We can do if you do mal scan, he wait for you because what's wrong? Mal scan. He wait for you because he's doing that loop. If you type anything, now I tell you I scan no malware detect. So this one is just joke. Okay, we're done with this. Let's go back to our directory. um, okay, that's fine. Let's continue the room. Sorry. Now, task 3, detecting discovery. Specialized discovery. After the initial discovery, After the initial discovery, the threat actor might also utilize more focused commands to achieve their goals. Data stealer look for password and secret to collect. Cryptocurrency miner queries CPU and GPU information to optimize the mining, and botnet scripts scan the network for new victim. Some malware can also combine all three objectives. For example, find and seek credential. For example, history, usually the history, find environment variable, home name, RSA keys. For example, here they're looking for CPU info. This one also all command. This is free memory and things like that. Scan internal network, the ping loop. We use this also if you are in CTF rooms sometimes to look for local open port or open network. Detecting discovery commands is straightforward with ODD. Remember, this one is good to install in Linux or other runtime monitoring tools. First, configure ODD to log write commands. So basically, let's see what TryHackMe has. etc audit rule D. Let's go there. Cut. Let's go to SU. SU. Cut SU audit. What's the file again? Rules. uh, what exactly TryHackMe is doing here? Oh, where's the other rules? I forgot where to find them. Oh, you get them from auto search. What I'm getting here? Never exclude. Where is the rules? Except the key exec. So that's what they do. Okay. Hmm. Oh, search, if you follow the logic, minus I, minus key, exec. Oh, it's a lot of them. Okay, let's come back later on to this one. It is very important to get, sorry guys, to get the context of the discovery command. For example, it is a red flag when a web server suddenly spawn who am I? Yeah, usually who am I is big flag. Or when IT members start looking for a secret with find and grab. On the other hand, a network monitoring tool is often expected to periodically ping the local network. You can get the context by building a process tree. For example, here you say you finding who am I. You start first looking for, this is the process ID. Look for its parent. Then when you look for its parent, then you go back and look for the parent. Who is the parent? At the parent 3898. Then identify its parent process. After we identify, you can see it's run a script, and then of course you can run who else, what this script also spawn. That's why we do the parent and we keep the ID to see all of them. Look for other process created by the same script. Now for this task, imagine you are received the alert about spike in discovery commands. The first thing you see is that ITC port user launched the hostname command. Can you continue the investigation of the VM and find out what really happened? Okay, this is too much noisy. Let's go to this command. The question is, what is the path for the script that initiates the hostname command? Now, because our information, we know hostname command was launched, so we can do, first of all, let's switch to root, because to do the O search, now we can do first, we can start with O report. O report to tell you we have number of login 2, failed 4, authentication 1, failed it's 4. We have 4 user, terminal 11, hostname 2, executable 71, 51. We have 72 commands. Let me make it big. So we go. So let's do now. We have the host search. We know the command I said is hostname. So we have one. The hostname process is this one, but who launched the parent is 3771. So we can just come here and look what is the process PID that launch, who's this 3771. Sorry, we did two dash. Now the 3771 that launched that host name, it's an IT home IT support, and the script is debug.sh. So here they give us already the first question, debug.sh. So we know the script debug.sh. Now after we found it, we can now go to cat home IT support debug, and what? I thought we switched to root. Cat home IT debug.sh. Now we have this. The question, if you say what was the last discovery command launched by the script? No, we can see what the script is doing. So if you can see it here, you can see the last one is this one. So that's the let's confirm is the one, because the PS is discovery. So let's see. This one is not dangerous. We can run it. Let's confirm. Or what we can do, because we know whose password, the history of root. What I was doing again? Let me all these search minus is big to host name, and then we went to, now we're looking for all the command that came from that process p that has PID, this one. Typing is not, I just type it 71. Now we got all of this, and then we can just grab the commands. So we just need, sorry guys, I did mistake. I'm looking for the parent of these commands. So who else? So now this would give us all the command, and then we can grab it should be cause the commandless bracket. Now it gives us you see, this one is what we got also in the same script when we did the home IT support debug file. You can see these commands are already that capture here, so you can see it start with host name and uname is a, you can see they are there, and then the last one was a PS, and you can see it's here. And then the head is not discovery, so the question is about discovery, so that's the question. So you can either look to it inside the script and then or here. The next question is looking at the script content, what's the email of the author? Email of the author. Okay, we have the author here. So let's go now to the next task. Motivation for attacks. Of course, motivation after discovery stage, the attacker usually reveal their motivation by installing specialized malware or taking action unique to some class of attack. Before jumping into technical review, let's consider the common goal of attack when breaking Linux system. So how can forget attack? This attack run at scale and focus on quick gain. For example, a threat group may continuously scan for internet for an exposed SSH with a try guess me password and get few victim every month. Install cryptominer and route to botnet use as a proxy, sending phishing emails and things like that. Ingress to transfer. So how do threat actor continue the attack and download malware like cryptominer to the Linux system? Of course, the famous one is always a wget, the curl, or they have SSH access. They would use as copy. So you can see the pattern and the keyword that you search. You search for wget, curl, or any SSH relating to scopy, scopy or FTP. Like other process-creation events, the command book can be logged with ODD and sometimes appear in bash history. However, there is a case where the process log aren't helpful. If the victim is reachable over SSH, an attacker can run as copy and SFT from their own system. In this case, you won't see the command in the victim audit log, but you will see a new SSH login. We'll see this later on. For example, here S copy from the attacker machine, a copy malware to the victim, connection open for SSH. So if you go to your log here, S copy, option 2, victim connected to the attacker. Um, because here in when you are inside the victim, you can also copy from the attacker machine to as copy. It has both ways, from attacker to victim or victim to attacker. To detect a victim, look for as copy command. This is if the attacker copy from inside the victim, so you can find as copy. But if it was copy from the outside, you will not see it. Additional detection in this task, you mostly rely on the to process creation event to detect malicious command and on authentication log to detect suspicious SSH login. Login, for example, network traffic, download from an IP previously seen, for example, in virus total. Let's see what virus total telling us. A download from suspicious or no malicious domains, such strange names, or download from a public service. What's this one? This one, for example, do an IP 101.99.94. This is a malicious one. You can see virus total OZ detected. What else we have here? A newly created file, for example, most of the time when there's a temp is flag, a newly defined name like exploit shell, yeah, or strange name. But most attackers they don't use these names. They make like update or something to confuse people. But no, antivirus or EDR antivirus alert trigger a new malicious file process. Now, for this task, look for command in the VM that may indicate ingress to a transfer. You can start with this to answer the question. Basically, here we're referring to look for wget, curl, ssh, scopy, sftp, things like that. Let me see what I have here. O search minus I minus x. So if I do, for example, wget, I get this. So let's put them next to each other. That's wget. If I do minus x curl, so we have the curl. A curl is downloading from dropbox-online.try thm, so it's TryHackMe. What it download? It download a file, and you can see usually when you see the temp, it's it's in the var, but and they create a temp folder, so it's a bit suspicious. This one suspicious in the var directory, and then you have sh. This is a bit flagged. Let's see. I'm not sure if is it in the room. Let's var temp helper. Why is not there? but it gone that file. Okay, it's not there. It was done from home Ubuntu. Hmm. Where am I? Where we are now? LS minus LA. Okay, so the curl download this, and then we have um, the wget downloaded these elastic things to an agent, elastic agent 913 Linux things. So what exactly the question? What is the full path to download the helper.sh script? The helper was done through um, the full path. Do they asking for? Oh, they're asking where it was saved. Okay, that's the helper we found. Which domain the elastic agent was downloaded from? That's the grep command, the wget that find it. It was downloaded from this .co, so you can get that one from domain. So you're not typing. You just went to domain. Okay. He said my machine terminated. Don't play with me. Yes, try hack me. It's not terminated. Why you say it's terminated? We are off. Yeah, try hack me. Yeah, try hack me and stopping machines in the middle of working. No, we dead. Let's wait for the new IP. Okay, let's continue until did we find all the answer for this question? And then said let's wait for and said which download file is more likely to be malicious. Yeah, you can see most of the this one. I think this is part of Elastic, so most is this one. So the one that was downloaded with the hell, this one was wget, this one was curl. So the curl one. Now, the next one you do this Dota 3 malware analysis. In the following task, you will see how the learned tactic look in the real world. As a reference, let's follow contact craft, and some report about Dota 3, a simple but well-known malware that infected and still infect many systems worldwide. Please note that some malware action in this task were simplified to improve readability. Now let's see how the infection starts. The botnet of more than 2,000 distinct IP across 94 countries scanned the internet for systems with OpenSSH. The botnet brute forced the system, mainly targeting the root user and trying to top the 1,000 weak password. If the password was guessed, one of the botnet hosts accessed the victim via SSH and continue the attack. The discovery, not from within SSH, sends the threat actor to make the discovery by running multiple commands in quick succession. Even from the first three lines below, you may conclude it is a cryptominer because you can see from the code. Let's see if we got the IP. We still not having the IP. Why it still say start the machine? Try hack me. Dota 3 malware again and again. This one contact craftsec Dota 3. Okay, that's the detail there. And then conclusion, and then we have hygiene. Oh, this one. Sun Education Internet Storm Center. Who, what? There's too many things. Who, what, one. Okay, I'll put a link, guys, if you want to read it. And then TryHackMe is playing games with me now. Hello. This is detect one. Then what's wrong with you now? Summary. A small number of user accounts were targeted by the actor at much lower rate. Route 1, Route 2, Web Route. We have the IP 58108. 58108. TryHackMe. Let's keep one session here first. Yes. Secure exclamation mark. Okay, we are in the system. Let's see what's going on here. So as I said, we can see it's trying to get CPU information and then the memory and things like that. And clear purpose, this one I'm not sure why doing which ls, maybe to check that ls is not compromised or something. The persistence, you can see, is doing this command echo ubuntu. They said changing the victim password, like in this case ubuntu, and echo minus e create new lines, because when you run password in linux, uh, you need to type your password twice, so that's why you have twice password. I'm not sure why this one is needed. This bash is not supposed to be here. I don't know, is this a mistake or something? Because you just need a pass w. I don't know why you need to go to bash and then you create a new remove the old SSH and then create your own SSH keys so you can control the machine. Detecting a cut, of course, for example, SSH we detected by accepted, failed login and things like that, and audit process usage for the command. Now for this task they give us, where is it? They give us an audit cdc. No, it's not inside the machine. So we have the audit log and auth log. Of course, you can do auth search. We just do the famous grep. For example, you can first let's see the failed login. How many are there in the auth log? You see the how many wc minus l. The 403 failed. Um, Forgot to get the IPs. You can see the IPs of 195. Most of them are 95. They all look 195. I mean 195.24, 192.27, 223. The same IP 124, 195.24, 27, 223. Oh, they all the same. The failed. Let's see the accepted one. I don't need the who's the accepted. The 45. Well, the 45 is not failed. Grab. Uh, Disconnect, accept. No fail in this IP. This IP logs straight. So what that means? It means This one they brute force the machine, fail, 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 and then this one took the password and login. That's the attacker login. That's disconnect, disconnect. There's no fail login for this IP. This IP is just straight login. The question is, which IP address managed to brute force? I'm not sure the question to say brute force, because if this IP was brute forcing, we can see the fail. There's no fail in this IP. So this IP just logged directly. So this IP was brute forcing, fail, 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 and this one is logged straight. So you can say the question is not brute forcing, it's more which one was able to access. That's all. The attacker IP, you can say. Which command did the attacker use to list the last logged in users? Huh. Look, we can do the easy way, because of all search that we have always. Okay, let's switch to root first of all. SU or search minus I minus if the same as they tell us in this command. You can see this. We can use now I'm confused. Yeah, we can use minus if. So we can use minus if auth log, no, not auth log, audit. Uh, we can search for that IP, because we know this IP is. So we can see this is the IP that, oh, it's only two. No, here it will be the session of this IP. So because I mean, the lazy way you can just do this, but I'm just to show you a different option to solve this. The lazy way is, if you want to be lazy, you can just do, what is that, the proc things that we did last time? Uh, I don't know, whether it's proc title or something. I always forget that name. What the title is? That proc title, yeah. Not grep you. We can just, but this one will not really give you straightforward, but it can give you an overall what the whole command in the system are. Yeah, but here is more like you're cheating, like you don't know what you're doing. Which one is the attack IP and which one are, you can see here, you name things, and you can see, for example, here, find notif thing, cat minus d4, that's what the cryptominer file, the thing, and then we can see is a scanning network here, and the last the comment that said for the users, where is it? This is scanning and then run the malware. But this one, it's not. It's more like a cheating when you answer like that. You name, I don't know where is that command. Is an SSH bash group. This is where the whole story start. Uh, yeah, that's your last command. But we do, let's not be so. This is like more cheating, because you're looking for the all commands. Now for us, minus x. Let's see the session SSH. SSH from that specific IP. Grab. What's that IP again? 45.9.148.125. So we have this is session that the SSH log. So we have a PID 5339. That's a PID 59. We have a 544 and a 5485. So we have, if you read carefully here, 39 session, I think second or session, I don't know what, this one, 39, you can see this one has a user login, these two they don't have. Let's, so we know, so now we can do what we did before, we can do that one, and now we're looking for all parent PID. Let's start for the bottom one. So if I do the PID, uh, let's not start from that. This is the correct session, but let's start from this session that look it doesn't have user login on them. This PID, the 484, that's the 5484 5485, and you can see it's an FTP. This one, I think, it's like FTP, SF secure FTP. So this is more, it's like the attacker in 5484, he was doing a secure session FTP. He's using FTP here, uh, and we can make it clearer what happened. Let's do that. Grep. So it's an FTP one. Let's go back to so we know this one is not uh, again did miss same mistake. So we have the 548 is not, so we have the, what's the next one, the 5440. 5440, this one, it's like it's not connected or something. So what left is the one of 5393 393 session. um, this is the PID. Let's see what exactly that PID before we grab anything. So this is the session. Now let's see what this session spawn, what other process run under this session. And then if I run now, this is the session attacker did the command on. Now if I grab the title to get a command, now we got, so the 5393 is exactly the session I'm looking for. So now we got the real session for the attack. So if we go now up, this is when you get a new session. I don't know what the group is doing there. Oh, this is just this is not attack command. This is when you do an SSH. It start doing the call for ls, doing the less command for binary file and things like that. Do the call and then message, and I think this one for not showing message from other user when you use wall and something like that. Here where the attacker start. So we start with ID last. So if I go to the question now, what's for last user? Because last is a command line. We go out of this now. The last is um, search back through var log wtmp for last user. So the answer is this is just last, because now we know the last. Then what else he did? PS minus p, looking for that 539. and then that's the binary was downloaded. What's the question? No, the binary is next one. Or which EDR process did the attacker look for with egrep? Okay, the egrep. What is the egrep? Am I answering the correct question, or this is minor setup? We got IP correct, we got lost. Did the attacker use egrep? Where is egrep? I can't see. Oh, that they are. Falcon, you can see they're looking for firewall. Falcon, Sentinel, and DS agent. In when we do letters, so we do D, ABDCF, F, Sentinel. So we start with DS agent. The the next one is Falcon, and then Sentinel, the Microsoft one. Sentinel. Now, a crypto mine. The next one is Dota 3 miner setup, task number 6. Crypto miner setup. Continuing to Dota 3 infection chain, the threat actor have maintained their presence in the victim and now decide whether to install crypto miner and supplementary malware. Since they already have SSH access, they simply upload to the 2 vice copy using the previous changes password. Below is an example of how it works. Of course, as copy, you copy from attacking machine to Ubuntu. That's how as copy, where you copy the file to a .temporary folder. After transferring the two .3 something, the attacker unpack them into hidden folder temporary, a common location for staging temporary malware. Take a look at the command below. For example, here cd temporary remove. What is remove in here? And then create another one, then cd, then unpack tar, then sleep, then cd, and do whatever you do. Lastly, the threat actor execute two binary from the archive. The first TSM, a customized network scanner that probe the internal network for other system with exposed SSH services. The second initial is an XMRig crypto miner that load the victim CPU. Okay, and use no hub to run in the background, so if SSH is disconnected, it's still running. That's why no hub command. Oh, is a scanning here, then sleep, and then a cd, and then run the malware. Detecting attack, we have through this room we learned how use log, for example audit log, creation of entrusted hidden file in temp directory, creation of file named like known malware such. Okay, audit log usage of command often observed in attacks such no-hub, and of course scanning the port and EDS. Okay, this one is said virus total example. Okay, so we continue running the same scenario. I think we already have the answer. What is the name of the malicious archive transferred via S copy? We already got these things already here, so we'll come back to this because we using as we already traced the SSH file. Let's see if scopy exists here. Scopy. Huh. Is no scopy. 1, 2, 3. The whole command in this session is here. It just say tar xvf kernel, so it's already in the system, so we know the file name. But where it copy from? let's remove our PID. I don't think there is an S copy in this machine, because if the copy was from the attacker machine, we'll not see it. Yeah, you can see ID last that we got before. So if he's downloaded somewhere, so he's not at all here. So where the hell will find it now? S copy will not be inside the auth. No, it will not be. It was just a session. So the only explanation is it copy from the outside, so you will not see the S copy. So the only way is like it's already inside the system. I don't see the copy exactly where it came from. The full command of cryptominer launch, we already seen this. Uh, it uses a knob, so it's already there. So after he just run it there. I think is this the correct? It's not the correct answer. Oh, the D. And then the IP scan. We saw the scan. You can see it is new batch minus C IP. Is scanning this one, the 1010. And you say IP in 1010 1 to 10. So you can see it's using from 1 to 10. So it's using this range from 1 uh, to 10. I'm just only My only thing left to get is this. I don't think we can see this copy because it was copied from the outside to inside. That's my best guess, to be honest. Yeah, guys, if you have different idea, please let me know in the comment. I think we're done with this room, so we can do the conclusion. In this room, you learned a lot about hack and forget attack on Linux, from the first discovery command to final impact. You also explored how to detect the attack stage using audit D and authentication logs, and even practiced your skills by uncovering a cryptominer attack. Key takeaways: hack and forget attacks are usually automated and performed at scale by botnets. In Linux, all attack stages mostly rely on pre-built commands like lscat, wget, and ssh. Your best approach is detecting malicious command is audit D and process tree analysis. Thank you everybody for watching. If you like, please press like and subscribe to the channel. And have a good day, and thank you very much.